Dear students, grade 9, today's lesson is a practice to calculate learning how to calculate the empirical and molecular formula. Let's look at today's lesson, learning outcomes. In this video, we're going to practice how to find and calculate the empirical formula, the molecular formula of compound, and yield. This is the first example. Okay, for this first example, for any problem, as we have learned, you have to read the question carefully, and this is asking us to calculate the empirical formula of a compound. That compound is called caffeine. You know, the caffeine, it's that compound found in coffee. Okay, so he's giving us not masses, he's giving us percentage composition. So actually this compound is made from carbon, hydrogen, oxygen, and nitrogen. A big compound. So we have carbon, hydrogen, oxygen, and nitrogen. Before we have said that when you're giving percentage composition, just simply turn it into grams. So the first step is to write the mass. Here is 49.84 grams. Hydrogen is 5.19 grams. Oxygen is 16.48 grams. Nitrogen is 28.85 grams. Now the next step is to calculate the number of moles. The number of moles equals the mass given to you, which here you have the masses, divided by the MR for each of them. So for carbon, the MR of carbon is 12, for hydrogen divided by 1, oxygen by 16, nitrogen by 14. Now let's calculate. Okay, so it's 44.48 divided by 12. Actually, 49, this is 49, sorry. So it's 49.48 divided by 12. Okay, it's 4.12. Now here it's 5.19 mole. And here 16, I think it's 1. 16.48 divided by 16, it's almost 1. Okay, yeah, 1.03 mole. And that will be 28.85 divided by 14. It's 2.06 moles. The next step, you have to divide on the smallest number of moles. This is the smallest number of moles here. So all of them will be divided by 1.03. 1.03. Okay, so 4.12 divided by 1.03 equals 4. It doesn't look like 4. Okay. So 5.19 divided by 1.03, and this is 5. Okay, this is 1. And 2.06 divided by 1.03, it's 2. So actually this is your ratio between these elements. So you have 4 carbons, 5 hydrogens, 1 oxygen, and 2 nitrogens. This is the empirical formula of caffeine. Okay, now of course you try that by yourselves later. This is the second example. For the second example, the empirical formula of trichloro cyanuric acid, okay, because there is cyanide here, CN. Okay, the active ingredient in many house bleaches. So cyanide actually is poison, so take care, guys. The molecular mass of this compound is 232.41 gram per mole. What is the molecular formula? So actually he's not giving any masses, but actually he's making it so easy. So you have the empirical formula, which is OCNCl. So actually this compound is made of oxygen, cyanide, and chlorine. And the molecular mass, the molar mass of that compound of the empirical formula, the MR for the empirical formula. So sorry, the MR4, actually this is the molar mass of that compound. This is the molecular formula. This is the molar mass of the molecular formula that we don't know, equals 232.41. Okay, the rule for that, to calculate the molecular formula, you have to divide the molar mass of the molecular formula, which is always given to you in any question, divided by the MR of the empirical formula. So, okay, this one you have it, it's 232.41. And this one you have to calculate, of course, it's easy because you already have the elements. So the empirical formula, molecular molar mass equals, we have one oxygen, so it's 16. Cyanide actually is 26. Let me check. I think it's 26. Yeah, it's 26 cyanide plus chlorine 35.5. Okay, let's add these. 16 plus 26 plus 35.5. It gives 77. Okay, equals 77. 16 plus 26 plus 35.5, 77.5. So this is the molar mass of the empirical formula, gram per mole. Now all you have to do is just divide 232.41 divided by 77.5. Okay, so it's 232.41 divided by 77.5, and there you have it, it's 2.9, rounded, it's 3. So all you have to do is just multiply that number to the compound. So this will give you O3, CN3, and Cl3. So this is your final answer. This is the molecular formula, O3, CN3, and Cl3. This is the empirical formula of that trichloroisocyanuric acid. Okay, let's check another question. Okay, now for the yield. Before we start the yield, actually the yield is calculating the percentage. Okay, remember when I asked you before that for any experiment, the actual results of the experiment is totally different from the calculated results, okay, due to human error. So everything in theory, actually it becomes different when you do it in real life or as a practical. So as an example, you have a chlorobenzene. Okay, this is C6H5Cl, is used in production of chemicals such as aspirin and dyes. One way that chlorobenzene is prepared by reacting the benzene C6H6 with chlorine gas according to the following balanced equation. So actually it's a favor. Okay, this equation is actually balanced, so you need no balancing. But first, when there is an equation, you have to first make sure that the equation is balanced. So here we have 6 carbons, 6 hydrogens, and here's 5 plus 1, 6 also. Cl2, 1, Cl, 2 Cl, so it's Cl2, so actually this is balanced. Now he's asking what is the theoretical yield of 45 grams, 0.6 of benzene reacted. Wow. So what is the theoretical yield? Sorry. So he's asking for the yield, the theory. So actually he's asking, in this case, we have to use that equation. So he's giving you the mass of benzene, right? And he's asking the theoretical yield. Yield, meaning by yield, is that compound, the one we're interested, which is chlorobenzene. So actually he's comparing now between two things, the C6H5Cl and the C6H6. So let's take them and just write them here. So C6H6 to C6H5Cl. Okay, from the equation, here you have, okay, let's try the mass, since he's talking about masses, the mass from the equation. Okay, if we calculate the mass here is 6 times 12 plus 6 times 1. So actually it's 72, right? Plus 6. 6 times 12 plus 6 equals 78 grams per mole. Okay, so for 78 grams per mole will give you that. Okay, let's calculate that. 6 times 12 plus 5 times 1 plus 35.5. Okay, so again, 6 times 12, which is 72, plus 5 plus 35.5 will give, wow, 100 grams. So if you calculate from the equation, that's in theory, from the equation, you need 78 grams of benzene to give or to have 112.5 grams of chlorobenzene. Okay, but when he did the equation, or when he did the experiment, he didn't use the 78, actually he used 45.6 grams. So how many of that will give you? Okay, now you cross multiply. So X equals 45.6 times 112.5 divided by 78. Now let's calculate that. 45.6 times 112.5 divided by 78. So actually it's 65.76 grams. So this is only in theory. This is only calculated from the equation he has given us. This is not us doing the experiment. Okay? So in theory, using the equation, and that's why it has to be balanced. Okay, in theory, only 78 grams, which is 1 mole, gives 112.5 grams of chlorobenzene. So in the question, actually he did not use the 78, he used only 45.6. So if you use 78, it gives you 112.5. But what if you used 45.6 instead? How many it will give you? Okay, so you cross multiply, you cross multiply 45.6 times 112.5 divided by 78, and there. This is in theory again. Okay, if the actual yield is 63.7, calculate the percentage yield. Okay, you calculated the actual. This is the actual, this is the real thing. But from your calculation, actually, it was 105 grams. This is what you actually had from the experiment by calculating. This is theory. To calculate the yield, you have to divide the real over the actual, and this is the result. This is the yield. So you divided what is really happening after making the experiment in real, divided by what you calculated in theory, and there you have the yield. Hope you enjoyed.